In the first part of this series, we looked at how a software program called JS8 Call was commanding an amateur radio transceiver, an Icom 7200, and we saw how it failed. In this second part, I'm going to start to look at the data that we recorded with Wireshark. But before we do that, I thought we'd cover some of the theory, some of the background information. So the first thing is that a USB bus is actually not a straight line bus. It has hubs. So we start off at the top of this diagram with a host controller. Then we have what's called the root hub, and we can plug devices directly into the root hub. So typically on the back of, say, a desktop PC or a desk side PC, I guess, you'll have lots of ports, USB ports, and they would be connected to the root hub. But then you can have a satellite hub. So, for example, I've got a Raspberry Pi, small satellite hub to enable me to attach more devices to my Raspberry Pi. And you can also have a hub and devices within another piece of hardware. And in fact, this is the case for the 7200. So if we look at the 7200 wiring diagram, you can see that the USB jack comes in here, and then you see a USB hub, and then we can see that there are two USB devices connected to that hub. There's a UART bridge, so this is bridging USB to asynchronous receive and transmit. And then we have a codec, which is used for sending and receiving audio signals. There are some different flavors of the USB protocol. One of them is called isochronous, and that particular flavor of USB protocol handles things like audio and video flowing on a USB port. That's how we have the setup in the hardware. I'll come back to this diagram later. So let's relate this diagram to the view that we see in the USB device viewer. Now, I've actually powered off the radio since we did the tracing, but I'm going to power it on again right now. So let's see what happens. Okay, and we can see that additional ports have appeared just here. We have the single controller, the root hub, then we have this subsidiary hub, and that subsidiary hub is the one that we saw in the diagram. So that's this one here in the circuit diagram for the transceiver. And then we have two devices. We have the UART, USB to UART bridge, and we have this device here, which is a USB audio codec, as it says there. And we can see that USB codec just there on the diagram. So another thing that I wanted to point out to you just while we have this diagram up is that we translate in this USB to UART bridge, we translate serial over USB into straight serial over a transmit and receive asynchronous circuit. And just to prove the point, if you look here, we have up the top of this diagram, we have a remote jack, and you can plug a serial connection directly into that remote jack and send commands and get responses to this CPU here directly without having to go via the USB. So this is how this all works. You may remember that the setup looks like this. We have JS8 running in the PC using hamlib, this library that normalizes the access to radios. We have a Silicon Labs serial driver that uses serial over USB, and then we have the USB driver stack, and then that takes us all the way through to the radio. And the packets that we're capturing are from the driver stack. So we're capturing at that point there. And as we said last time, hamlib connects to the transceiver through COM port 3. Now a point that I haven't covered is that actually Icom have their own control protocol. It's called CIV. I believe it's Communication Interface 5. So here we see an extract from the manual that comes with the transceiver, and this gives details of the actual command structure. So we can manually decode the commands using these pages. So this is the actual layout of the commands, and then here's the meaning of the different values in the command and subcommand fields of the packets that flow backwards and forwards. Now I started to do this by manually decoding it, but I soon got bored with that, and so I managed to put together a very basic protocol decoder for Wireshark. So I'll show you how that works. So if we start Wireshark, and I'm just going to start up, just going to open the trace file. And we know that the communication was on USB address 3.7.1. So let's just filter down onto that. And so we see all these types of packets. Now I can go in here and I can manually decode each of these packets, but as I said, that gets a bit boring. So what I did was I wrote a very basic protocol decoder. And we can install that by going to my GitHub repository, which is just here, github.com credible58, and then it's CIV-7200. I'm looking at the master file there. Let's back up a little bit and go to the actual, there we go, to the actual directory. And here's the plugin. It's written in the Lua programming language. Here's the trace file that I'm using in this video, so if you want to try and repeat what I've done, you can by all means download that trace file, and the README just tells you that you need to install the plugin into a particular directory. Now the place you install it is in, if you go to users, actually let's show you the correct way of doing this. What you should do is go into Help, About Wireshark, Folders, and you can see that personal Lua plugins should go into App Data Roaming Wireshark plugins, and if you click on that it will take you straight there, and you can see that I've dropped the plugin into that directory. So that's how we get the plugin. Now you have to restart Wireshark after you've dropped the plugin into the directory. And the other thing you have to do, you can see that I don't actually have it activated at the moment. You have to go to Analyze, Enable Protocols, down here type in CIV, and there it is, CIV-7200, and click OK. It'll rescan the trace file, and then you'll start to see more meaningful information in the info line. And I found this a much quicker way of working and describing what was going on. Okay, so one other thing that I'd like to cover just while we're here, this USB address thing can be very confusing, because if you come in here and use the USB device address here, for example, if I prepare that as a filter term, you can see it says USB device address, and it's different. And then there's also a USB address, and if I try putting in there 3.7.1, you can see that it won't even take it as a string the way it did before. I don't think it will take it as a dotted decimal either. So this can all be very confusing. The actual filter term you need is the one which is USB.addr, that one. So that's the filter term we need to stick with. Okay, so if I apply that filter term, Okay, so now I've shown you how to do this. You can see that it's the CIV protocol, and you can cross-reference that obviously with the entry in the manual if you have a 7200. For general knowledge here, don't worry too much about the particular aspect of this Icom transceiver. It doesn't matter. We're just really trying to look at the way USB works. Now, JS8 will track the frequency on your transceiver. So not only can you set the frequency through JS8, which I'm not going to be able to do because it's I've got it unplugged at the moment, but I can set the frequency up here in JS8. But also, if you change the frequency on the transceiver with the dial on the front, the JS8 will track that change in frequency. And the way it does that is it just repeatedly polls for the frequency. So if we look for this read operating frequency command, let's go for that, and we apply that as a filter. You can see at this point here I changed from 10 meters down to 20 meters. This is called the 20 meter band, so it's 14 megahertz. Then I went back to the 10 meter band, and then I tuned it differently there. And as we go down through this trace, I think I changed it once more, didn't I? When I was messing around. Nope, can't see any other changes. So, but what you do see obviously is it's repeatedly polling for the frequency. Okay, so let's clear that filter and just go back to the filter for the device. Okay, now if you remember, what happened was towards the end it just seemed to stop working, and the little cat logo went amber, and then it threw the error. So if I come all the way down here to the bottom, we'll start to see what happened around the time of the failure. Now the first thing I notice here is you see that it's repeatedly trying to read the operating frequency, but it's not getting any response. But there's something else as well. If we go back to the previous point where it did read the frequency correctly, if you notice, it does a command, read the operating frequency, and that gets echoed back. Now the CIV connections, if we go and have a look at the connections on the diagram, this connection here actually appears to be a single wire. So it's sending and receiving on a single wire, which I only found out about this by reading around lots of things on the internet, but it seems that that's what happens. And it also seems that when this UART does a send, it hears its own command being sent, and it gets echoed back through the USB bridge, back through the hub, back through the jack, and then back towards the PC and the JS8 software. And what I did find was that there are mentions on the internet about if that echo isn't working, it will definitely fail, and that certainly seems to be what we're getting. So it seems as though we've stopped listening. So not only are we not seeing the echo, we're not actually seeing any responses to the commands. So if you look here, there was an echo there, there was an echo there, and we got a response. Then we did a read frequency there, which is only, less than a second later, 900 milliseconds later, and we don't get an echo and we don't get a response. And we don't get an echo and we don't get a response there, and from that point on it just fails. So what's caused it? Well, that's the $64,000 question, and I don't know that I can tell you right now. I'm going to do another video following up from this one, but obviously something has gone wrong here. Now I suspect it's not actually a problem with this send and receive on to device 3.7.1. I have a feeling something has happened on the out of band channel. As this was the last command that was good, I can mark that frame. So let's mark that one. And as this is the first command that doesn't get a response, I can mark that frame. So we'll mark that one as well. Now what we're really interested in is the packets between those 2 points. So one thing I can do is I can say that I want all frames that have a number less than or equal to. So we'll prepare that as selected, but we'll change that to be okay. And then we go back to the other marked one. You can do search for marking actually. But we'll do it this way for the moment. There it is. And so what I also want to do is say that I'm only interested in frames that frame number is greater than or equal to 173206. So that narrows things a bit to this set here. The other thing is I'm not really interested in anything other than what's on device 3.7. So what I can say is and USB 3.7.0 or USB, close the brackets. Need to put quotes around it. It's a bit finicky. Okay. So, somewhere in this lot, something's gone wrong. And I guess that will be the subject of a future video. So I hope you found that interesting, and I'll try and do the next video a bit quicker than I did this one actually. I apologise for the delay in getting this one out. But I hope to speak to you soon.